Right. Grundpotensform, which in English is often called scientific notation, or even sometimes exponential form. When we talk, there's a different word in Swedish as well that is called potensform, and you can wonder what's the difference then between potensform and grundpotensform. Well, potensform can be anything times 10 to the 3 or something like that. It can be any number here. It could be 20, it could be 120. It's got a number in front, and then it's got some sort of increase base, okay, an exponent, we call this type of number. But when it's in what we call the grundpotensform, it's one number and then it's the decimal point, always. So you have to have a number that isn't 0. You can't have this times 10 to the 4 and call that grundpotensform. You'd have to change that number to 3 times 10 to the power 3. Then it could be called grundpotensform or 3.0. So grundpotensform always has one real number that isn't 0, then a comma or a decimal point, and then the number. So what number is this in reality then? Well, if we were to take the first one, 1.3 times 10 to the 5. In order to understand this one, we really have to understand exponents first. So let's just look at a few exponents. Exponential form, 2 to the power of 3. What does that mean, and what do the different numbers mean? Well, the number here, the 2, is called the base number. In Swedish boss, so it's exactly the same. The number up here, that is to the power of, that number is called the exponent. Again, exactly the same name in Swedish as in English. Okay? So that is called the exponent, that's why it's called exponential form. This number is called the base number. So if we were going to work out 2 to the power of 3, we'd have to understand what this symbol means. 2 to the power of 3 means 2 multiplied by itself 3 times. And 10 to the power of 4 means 10 multiplied by itself 4 times. So this is easy to work out, 2, 4, 8. It gives us a nice simple number. This one is really the same as 10,000. So whenever we see 10 to the 4, we don't have to write the 10 times 10 times 10 times 10. We can just think of it. The number 4 here is telling me how many zeros I've got. Okay? So it's really useful. So 10 to the 3 would have 3 zeros, it would be 1,000. 10 to the 6 would have 6 zeros, it would be 1,000,000. Yeah? So this is the important thing to understand with exponential form. Once you understand exponential form, it makes putting things in scientific notation very easy. Because let's have a look now. What does 1.3 times 10 to the 5 mean? It means 1.3 multiplied by 10 5 times. This step we can miss because it takes a lot of time and it's sort of going against the whole idea of saving time, which is why we put things in scientific notation. So if we want to know what this is as the real number, it's 1.3 times 100,000. 5 there, 5 zeros here. So this number is 130,000. 1.3 times 100,000 will be moving this decimal point 5 places. So what I would do is I'd probably skip both of these stages once I'd understood what scientific notation is, and I would just take my 1.3 and move the decimal point 5 places back. 1, 2, 3, 4, 5. 1 place for every number in the exponent. Okay? So what do we do then when we have this number? 1.26 times 10 to the minus 2. What does that mean? Well, the times 10 to the minus 2 actually means 1 over 10 squared. So the minus number here is telling you that it's 1 over that number squared. Always. Okay? which means that 10 to the minus 2 actually means 100th. There's another way of thinking about this as well. You can think of 10 to the minus 2. We know that 100th is the same as 0.01. 100th to the minus 2. So let's say that we have the number 1 here. 1 times 10 to the minus 2. When it was times 10 to the 5, we moved the decimal point 5 places in the right, to the right, making the number much larger. When it's times 10 to the minus 2, we do the opposite, because this actually means dividing by 100. So we would take our 1.0 and move it 2 places to the left. 1, 2, putting the decimal point here, 0.01. So when we are multiplying by negative numbers, we are dividing by that exponent, or we are moving the decimal point 2 places to the left, making the number a factor 100 smaller this time. Okay? So let's look at 1.26 then, times 10 to the minus 2. How would we manipulate that? We would do it by either 1.26 divided by 10 squared, which is 1.26 divided by 100. To divide by 100, we move the decimal point 2 places to the left, 0.0126. 2 places to the left. Or we can think of it as 1.26 times 10 to the minus 2. The number here is minus 2. So I would move the decimal point 2 places to the left, 0.0126. 2 places back. Okay? And you get the answer directly. So you can use either of those methods when you have to convert. So how would you make and convert this one then into grundpotensform? Well, you'd do exactly the same thing. If you had the number 0.0126, if you were going to turn this into the number 1.26, because I've told you it has to be in grundpotensform, you'd have to move the decimal point 2 places to the right. It means you're actually multiplying this number by 100. If you're multiplying this number by 100, you at the same time have to divide by 100, which is the same as times 10 to the minus 2. Because otherwise you can't just multiply one number by 100 and then not do the same thing to the other side. Okay? So this is one of the ways we could present scientific notation. So what you get to do once you've done it a few times, let's take a few different ones. If we were to put the number 12.3 in scientific notation, what would that be equivalent to? It would be equivalent to 1.23 times 10 to the power 1. 1.23 times 10 would give us 12.3. This would now be in scientific notation. If I had 139.4 and I wanted to put that in scientific notation, it has to be 1.394 times 10 to the power. How many places have I moved the decimal point? 2 places to the left. So it would be times 10 to the plus 2. So these numbers are identical. So when you're doing the other way, 0.000124 is the same as 1.24, but now you know it's got to be times 10 to the minus. When we're going this way back, we're moving the decimal point this way to get 1.24, you're always going to have a minus here. How many places have I moved my decimal point to get from this number to 1.24? 1, 2, 3, 4. So it's going to be times 10 to the minus 4. So you're just looking at how many places you've moved the decimal point. And if you're moving the decimal point backwards to make the number bigger, you're going to have a minus number up here. And if you're moving the decimal point to the left to make the number smaller, you're going to have positive up here, always. So that is grundpotensform, which we also call scientific notation. The advantage of having things in scientific notation are really when you get very, very big powers. So let's say that we had 4.8 times 10 to the power 8 divided by 2.4 times 10 to the power 4. If you want E-level points, you can put this in terms of moving the decimal point 8 times, 1, 2, and then 6 zeros. This number is that number, 480 million, and then you can divide it by 240,000. 1, 2, 3, whoops. 24,000. So you could just cancel zeros here. 3 zeros up there, cancelling these 3 zeros down there. 24 goes into 48 2 times, and then all the zeros that are left over. This will give you E-level points. And if they've asked you to calculate it in potential form, you won't even get E-level points. So this is why it works, but now I want to teach you how to calculate it in exponential form, which is the easy thing. So we put it as 4.8 times 10 to the power 8 divided by 2.4 times 10 to the power 4. The first thing we think of is 4.8 divided by 2.4 goes 2 times. I've given you nice easy numbers here, okay? Then 10 to the power 8 divided by 10 to the power 4, we work out like this. 8 divided by 4 gives us 8 minus 4 in potential form. So the answer ends up being 2 times 10 to the power 4, which is 20,000. So this method is much easier than this method and takes away your risk of making silly mistakes. What if I'd asked you to multiply those two numbers instead then? Well, it would have looked pretty, let's take slightly simpler numbers. It would have looked pretty silly if I was going to write 400 million multiplied by 20,000. Like that, wouldn't it? We could have done it, but it'd just be a ring of numbers. Whereas if we keep it in exponential form, in scientific notation, 4 times 2 is 8. So our answer is going to be 8 times 10 to the power of, and here when we're multiplying exponential form, we actually add the powers. 8 plus 4. So the answer would be 8 times 10 to the power 12. Which is really quite nice. It saves all of these zeros going back. Here we should have 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have it anyway. So we can prove to ourselves that that's what it would be if you want to check it in the beginning a few times. But this is the beauty of scientific notation. It only works like this in multiplication and division. Okay? If I had asked you to add these two numbers together, you could absolutely not use this rule at all. Got nothing to do with adding the powers. You would have to split up your numbers in this separate form and then add the numbers separately. Okay? You can't add or subtract in exponential form. One of the key rules. Okay? You have to then split up the numbers, put them under each other, and do the subtraction. This only works for multiplication and division, this technique. When you are multiplying, you add the exponents, 8 plus 4. When you're dividing, you subtract the exponents. And if you wonder why, set up the numbers like this and you'll see that that's why it works. Okay? The number of zeros cancelling or adding together. Here we had 8 zeros, here we had 4. How many will we get in the final number? 12. So it's like as though we are adding all the zeros together to get your 12 zeros. Okay? So that is potence form, where it can be any number. It doesn't have to be one decimal point in front of the power. Grundpotence form, one number, decimal point, then the powers. Exponential form, 2 to the 3, 10 to the 4, 5 squared, 3 to the power 3, 5 to the power 5. Any number that is multiplied by itself that number of times is called exponential form. And scientific notation is the same as what you guys call grundpotence form. So, we take a few